One post. That was the launch. On July 21st, 2026, Jack Dorsey announced Buzz as a group chat for teams of people and agents. The important part is the pitch underneath. Model agnostic, decentralized, self-sovereign, and open source. Ambitious? Absolutely. But that still doesn't tell us who actually built it. And that phrase, group chat, is the clue. So let's trace this back to the official source. Instead of guessing from the headline, Block's own launch article gives us the missing context we need right now. This is the attribution that matters. Jack announced Buzz, but Block built and released it. The article describes a free open-source collaboration platform where humans and AI agents work together inside a shared workspace. One page down, and yes, the B branding is doing a heroic amount of work here. One more scroll. Block says separate tools leave teams bouncing between isolated requests, fragmented context, and disconnected systems. Buzz is meant to provide one common room: channels, threads, messages, files, code repositories, and automated workflows. Agents get cryptographic identities and defined permissions, and the platform runs on the Nostr protocol, pronounced Noster. In plain English, this isn't another lonely chatbot tab. It is trying to become the workspace around the agents. That distinction matters. Now, the product itself. The launch promise lands us right here, on screen, at buzz.xyz. The current site calls this a developer preview, which is a useful reality check. Buzz is free, open source, and still openly inviting people to test the early stages. So the fair beginner takeaway is simple. Buzz is a shared workspace for humans and AI agents, built by Block and announced by Jack Dorsey. It is not a proven replacement for Slack or GitHub, and the launch post doesn't magically make every feature production ready. In the next lesson, we'll map the product before touching a single control, and because this course goes feature by feature, we'll keep separating what Buzz promises from what the current build actually does. Buzz looks like chat, but the useful model is this. Buzz coordinates shared work while connected runtimes do the specialized work. This channel is one room. Chat on top, coordination underneath. Let's start with the outer boundary. The community. Hover the community. This URL points Buzz at a relay, the service storing and serving this community's channels, messages, people, agents, rules, and signed events. Switch relays, and you've switched workspaces. That's the outer boundary around the shared work we're mapping. Back out once. That closes the profile menu. Open the channel controls. Inside a community, channels are the rooms. General is where conversation lives. People post, agents get mentioned, and everyone's working against the same visible context. Open the canvas. A canvas is a markdown note attached to the channel, good for a brief checklist or decision log that should not disappear into chat history. Ours is empty, so Buzz says so. No demo smoke machine required. That note stays attached to this channel. Now, Pulse. Pulse is the public update feed separate from inbox and channel chat. Filter it by everyone. Follows, likes, agents, or your own posts across the community. Right now, there are no public notes. Empty is still valid. Public context, not inbox. Next, projects. Projects is the repository layer. Buzz can surface published projects and organize issues, pull requests and activity around the shared workspace. We have none yet. Useful information, not a malfunction. Now meet the agents. Agents are the workers, each with a separate Buzz identity. Fizz, Honey, and Bumble are managed here with a team below, but an agent still needs a runtime like Codex or Hermes, plus a model, permissions, and usually a working directory. Buzz coordinates the request and result. The runtime does the work. And finally, the automation layer. Workflows listen for a trigger, like a message, reaction, schedule, or webhook, then run steps. A saved workflow isn't a successful run. Obvious until automation fails confidently at 2 in the morning. This empty list and create workflow are only entry points. Here's the map. Community on a relay, channels for conversation, canvases for durable context, Pulse for updates, projects for repository work, agents for execution, workflows for automation. Buzz is the operating room around the work, not the model pretending it's the whole hospital. That's the mental model. Buzz moves fast, so the quickest way to teach it badly is to treat every visible switch like a finished promise. Let's pin down what we're actually using. Open the profile menu, then Settings. The version sits in the lower left corner, 0.5.3. That number matters because Buzz is pre-1.0, and a lesson without a version ages like milk in direct sunlight. That's our anchor. Open Experiments. Buzz describes these features as functional, but still being refined. The 5 switches in this build are workflows, projects, pulse, forum channels, and agent-managed profiles. Here is the important distinction. Preview describes how Buzz exposes a feature. It isn't a court ruling that the whole feature is fake. But the pinned documentation says the relay, channels, threads, direct messages, canvases, media, search, audit, the desktop app, agent tooling, YAML workflows, and Git services work today. It separately flags mobile clients and workflow approval gates as unfinished. Even the pinned docs disagree slightly about Huddle lifecycle maturity, so we won't promote that path from interesting to dependable without testing it ourselves. Let's test what one preview switch actually does. Turn workflows off. Buzz confirms that Workflows is a preview feature. Return to the app. The Workflows item disappears from the sidebar, although the page we already had open can remain visible. The toggle changed navigation exposure. It didn't run, delete, or validate a workflow. A toggle is a curtain, not a certification. Now restore it. Open the Profile menu. Go back to Settings. One level deeper. Open Experiments. There's the switch, and turn Workflows on again. Return to the app. Workflows is back in the sidebar, and every other preview setting stayed untouched. So keep 3 labels separate. Works today means the pinned project documentation claims the surface exists. Preview means Buzz lets you expose a feature that is still being refined. Being wired up means the maintainers call out incomplete behavior. Those labels don't guarantee your exact use case. The practical rule is simple. Pin the version, read the primary source, then test the exact path you plan to rely on. Less magical, much more useful. Now we build on facts. Start at buzz.xyz. That's the Get the App button. It finds the current package for your system. Open the official release page before you download anything. At recording time, Buzz Desktop 0.5.4 is the latest release, and the notes tell you what changed and what got fixed, which is the quickest compatibility check. So, scroll down. They matter when an update changes behavior. And jump to Assets. Mac uses DMG. Linux offers App Image or DEB. Scroll once more. The Windows x64 setup file is the installer. Alpha unsigned means Windows may warn you. Buzz is already installed here with an update waiting, so we won't reinstall it. Press Ctrl, for settings. This machine is on 0.5.3, one release behind the page we checked. Compare versions before blaming yourself or the bees. We're keeping it unchanged for the rest of the course. Buzz is already configured, so we won't erase a healthy identity just for this lesson. A fresh install creates or imports one, backs it up, checks agent harnesses, then offers model, community, and profile setup. They remain available. The shortcut here is Control, This is the post-setup control room. First, confirm your relay URL and that the service is reachable. If first launch still cannot connect, collect the actual error before blaming the firewall. At this point, vibes are not useful diagnostics. Before changing anything, verify the Windows prerequisites. Buzz expects Git Bash from Git for Windows, not WSL's Bash launcher. Agents and updates come later. This machine runs 0.5.3 with 0.5.4 downloaded, so we won't update mid-course. And that preserves a known good setup while we troubleshoot one variable at a time. If a firewall block is confirmed, allow the verified Buzz app, never disable Windows Firewall. Button mashing makes truly spectacular disaster documentaries. Buzz separates the profile people see from the identity that proves it is you. Your display name, avatar, and bio are editable. The key pair underneath isn't casual profile decoration, and your public key can identify you while the private key gives account control. That is the danger. If someone gets that private key, they can sign as you. If you lose it without a working backup, Buzz can't reset it. In Profile, the identity card leads to the public key, NIP05 handle, and a masked private key row. I'm leaving that row closed because tutorials should not moonlight as credential leaks. For a real backup, choose Create Backup. Use at least 12 characters, save the encrypted encryptsec file somewhere private, store the password separately, then use Test Backup. A green check matters more than a file you have never restored. Buzz uses NIP49, and Windows stores the live key in Credential Manager. This identity stays untouched. In Buzz, a community is the whole workspace behind one relay address, not just a folder. Shared agent work lives here. Open Profile. Hover here. Community controls, choose Add. Buzz gives you two routes: create a new workspace or join one you already have. Create is for a fresh relay you control. Join connects this identity to an existing team space, so the choice is simple and it stays reversible. Choose Create. The Create route hands off to Builder Lab, which hosts the relay. Your private key stays on this device. I'm stopping here because signing in would change a real account, and that's deliberate. Only continue when you mean to provision that workspace. Go back. Now choose Join. The Join route accepts a community URL or invite link. Verify the host and sender first. Prefer short-lived, use limited invitations, and never expose an API token. After joining, check the connection state and confirm the expected workspace loads. Don't rush this. That's the proof. Close it. We're back in the current workspace. Use this same menu to switch communities. Your identity can travel, but each relay keeps its own workspace state. Buzz is one sidebar with several work surfaces. Channels and DMs live below, while the main tools sit above them. Search. Global search is Control-K, recent activity, channels, and common navigation actions, all in one place. Close that. Back to drafts. Open the inbox filters. Use filters for projects, mentions, threads, agents, reminders, and drafts. Close that. Inbox collects DMs, thread replies, and mentions. That saves you from hunting through every channel for the next thing that needs you. Here's Pulse. Pulse is the wider activity feed, public notes, people you follow, liked items, and agent activity. Think Signal, not chat history. Over to projects. And projects is the repository workspace. Repositories published to this relay appear here, ready for human and agent collaboration. Now, agents. And this roster is where you create, start, stop, and organize agents and teams. These cards are identities. Runtime setup lives in settings. Workflows. Workflows turns repeatable jobs into YAML-defined automation with approval gates. Empty is fine, we'll build one later, instead of waving at the button. Profile menu. This menu handles status, community switching, feedback, and settings. Tiny menu, surprisingly high rent. Into settings. Settings is split into personal, communities, and app. Sections appear only when the feature is enabled, and your role allows it. Appearance. Choose system light or dark, then a theme. This is cosmetic, so pick what keeps long sessions readable. Notifications. For a sane baseline, keep DMs, mentions, thread replies, and needs action alerts. Leave notify while viewing off, and you'll avoid duplicate pings. Simple beats noisy. Local archive. This saves selected relay data to a local SQLite database. Agent observer frames and turn metrics are optional. It's retention, not an identity backup. Agent settings. Here, Buzz controls addressed agent behavior, sleep prevention, prerequisites, and runtimes. Git bash is available on this Windows machine. Scroll down. Codex and Hermes agent are both ready. We'll use Hermes for investigation and research, and Codex for implementation, always with a real app mention and a visible reply. App controls. Open experiments. Experiments currently exposes workflows, projects, Pulse, forums, and agent-managed profiles. These can move or disappear between releases, so verify before teaching them. Next, compute. Shared compute isn't available here because Mesh LLM support is disabled. That's a current limitation, not a missing setup step. Now open the mobile panel. Mobile pairing uses a QR code, end-to-end encryption, and a verification code. Never publish a live pairing QR in a tutorial. Finish on updates. This machine is on 0.5.3 with 0.5.4 already downloaded. Finish active work, check the release notes, then update and retest anything your course depends on. Back to Buzz. That's the map. Conversation stays on the left. Focused work lives in the main surfaces, and risky or evolving features stay behind clearly labeled settings. A clean Buzz workspace starts with one boring rule that saves a ridiculous amount of future pain. Every channel gets one clear job. Today, we're building that structure from scratch. We will create 4 durable rooms, separate shared work from sensitive operations, organize the sidebar, tune attention, and finish in the channel browser. No mystery meat navigation, you will see every click. Start with Control-Shift-N. That opens create a new channel from anywhere in the main app, which is much faster than hunting for the tiny plus button. Channel type gives us ongoing or temporary. Ongoing is the right default for durable knowledge. Temporary is for work with a real expiration date, like an incident or launch room. Visibility is the second big decision. Public channels are discoverable by the community. Private channels are invite only, and access follows membership rather than wishful thinking and a secret-looking name. Our first channel is product. Keep names, lowercase, and predictable. In the description, define the boundary, roadmap, customer feedback, and product decisions. A good description quietly prevents 3 meetings. The product channel is public and ongoing. That means it can become searchable team memory instead of another private notebook that only one person remembers exists. Next comes engineering. Same durable public defaults, but a different contract. Implementation plans, code review, and release readiness belong here. Product decides what. Engineering works out how. And notice how much faster the second channel is. Once the decision model is clear, the form becomes almost mechanical. Name, boundary, lifecycle, visibility, create. Research gets its own room for questions, sources, experiments, and findings. This keeps half-tested ideas out of product decisions while still making the evidence easy to find later. A useful channel isn't just a topic label, it answers a practical question. What should I post here, and what should I move somewhere else? Ambiguity is the real notification spam. Operations is different. It covers access, incidents, and sensitive operating decisions, so this one becomes private while staying ongoing. Confidentiality is a real need here, not decorative paranoia. But private doesn't mean invisible to its members. It means people outside the membership can't discover or enter it. Anyone who belongs to the room can still find it normally. We now have product, engineering, research, and operations. 4 channels is enough structure to separate responsibilities, but not so much structure that finding lunch requires a map and a Sherpa. Before organizing the sidebar, remember the hierarchy. Create a channel when the audience or access boundary changes. Use a thread when the conversation simply branches inside the same audience. But if every task becomes a channel, the sidebar turns into a graveyard. If everything stays in general, search becomes archaeology. The sweet spot is a small set of durable, purpose-driven rooms. Temporary channels deserve an explicit cleanup date. Use them for a launch sprint, incident, or time-boxed swarm. If the knowledge should still matter next quarter, choose ongoing instead. Public by default is a strong collaboration rule because people can discover prior decisions without asking permission. Switch to private only when the content or membership genuinely requires it. Descriptions should use plain nouns and verbs. Say what belongs, and if confusion is likely, say what doesn't. Clever copy is fun. Clear retrieval is considerably more useful. Right-click a channel to open its management menu. Copy, read state, mute, star, leave, archive, and delete all live here, along with move to section. So remember, archive is the safe lifecycle action when a room is finished. Delete is irreversible, so this lesson doesn't touch it. A clean workspace isn't improved by enthusiastic data loss. Hover over Move to Section, and the submenu appears, because we don't have a custom section yet. New Section is the only destination available. Create a section called Core Work. Sections change sidebar organization, not channel permissions. They are a navigation layer, not a security layer, which is an important distinction. Operations moves into core work immediately. The lock icon still communicates private, while the section simply tells us this room belongs to our main operating system. A section should describe how you scan the sidebar, not recreate your org chart. Core work is useful because it groups the channels you revisit constantly, regardless of department names. You can keep public and private channels in the same section because access is still enforced per channel. The grouping doesn't leak the private room to people who are not members. Keep the number of sections low. If you need a section for every 2 channels, you've probably invented folders as a hobby instead of improving the workspace. Open Products context menu. Star and mute sit beside structural controls because they are personal attention settings. They change how you see the room, not who can access it. Star Product and Buzz lifts it into a dedicated starred group. That's your personal priority shelf, perfect for the handful of rooms you need to reach all day. Starring isn't a popularity contest and it doesn't notify anyone. It's simply a local navigation choice. Keep this list short enough that the word priority still means something. The starred shortcut menu focuses on attention controls, so move to section isn't shown from this shortcut. We will briefly unstar product, assign its structural home, then star it again. Remove the star from product for a moment. This doesn't remove the channel or its content. It only returns the row to its normal section location so we can organize it. This is the useful mental model. Sections answer where a channel belongs, stars answer what I need fast. One is structural, the other is personal attention. So because those layers solve different problems, a starred channel can still retain a custom section assignment even when the starred group takes visual precedence in the sidebar. Back on product, open move to section. Core work now appears as a real destination alongside the option to create another section. Choose core work. Product joins operations under the same durable grouping while its public visibility and ongoing lifecycle remain unchanged. The sidebar immediately reflects the move. This kind of small, visible organization is worth doing while the workspace is young. Later, it becomes a migration project with feelings. Engineering follows the same path. Right-click, move to section, core work. Repeating a good pattern is exactly what a clean workspace should feel like. The submenu confirms the destination before anything changes. That visible checkpoint matters because nearby items include leave, archive, and delete, which have very different consequences. Engineering now sits with product and operations. Alphabetical order inside the section keeps the result predictable without requiring manual drag-and-drop choreography. Research is the final structural move, but first we'll use it to demonstrate attention control. This is where mute is useful when a room matters but doesn't need constant interruption. Muting doesn't leave the channel, hide history, or change permissions. It reduces attention pressure. You can still open the room whenever you want and catch up deliberately. Open Research's menu and choose Mute Channel. Use this for noisy rooms where you prefer intentional check-ins over a stream of ambient pings. The control changes immediately. In a real workspace, leave it muted only if your notification policy supports that choice and the team doesn't expect instant response there. Open the same menu again and restore notifications. We're demonstrating the reversible control, not quietly leaving the course workspace in a surprising state. Research is unmuted again. That final state is deliberate. Nothing is archived, nothing is deleted, and no channel is left with a hidden attention setting from the demo. Now move research into core work. The menu path is identical, which makes this easy to teach to a team and easy to audit later. Choose core work as the destination. The section now represents the 4 durable operating rooms we designed at the beginning of this course. The structure is now complete. Engineering, private operations, product, and research share one sidebar group without sharing one visibility policy. We can now restore the personal priority layer. Product belongs in core work structurally, and it can also be the channel we want one-click access to every day. This combination scales well. A few meaningful sections for everyone, plus a tiny starred list tailored to each person. Shared order, personal speed. Open Product's context menu one last time and choose Star Channel. The final sidebar now has starred product, core work beneath it, and the remaining default channels separate. That visual hierarchy is simple enough to understand at a glance. Channel hygiene isn't a one-time ceremony. Review the workspace occasionally, archive rooms that are genuinely finished, and rename vague rooms before their ambiguity becomes institutional folklore. Avoid deletion unless you truly need the data gone. Archive preserves history and removes active clutter, which is almost always the safer end-of-life choice. Also resist creating private rooms by reflex. Privacy is appropriate for access-sensitive work, but too many hidden rooms fragment decisions and make the wider team repeat the same discovery work. To inspect the wider directory, start with Search Everything. Typing Browse looks sensible, but the text box searches channel content and names, so it returns no match here. This no match result is useful. Browse Channels is a navigation action, not a channel named Browse. Clear or reopen search and use the Actions area instead. Global Search mixes recent destinations with common actions. When the list is long, scroll toward the bottom. The action shortcuts stay grouped together and clearly labeled. And this route is easy to remember. Search Everything, then Browse Channels. The 3-dot menu beside the Channels heading only controls sorting in this installed version. There, it's under Actions, alongside Create a New Channel and Create a New Agent. Choose Browse Channels to open the full directory. The directory is where you discover public rooms, revisit channels you've joined, and inspect archived rooms without turning the sidebar into a permanent catalog. But remember the private channel nuance. A private room can appear here for its own members. People outside that membership should not be able to discover or enter it. Browse channels opens with all channels, joined and archived tabs. The search field can also lead into channel creation when the room you need doesn't exist. Our 4 rooms appear with their descriptions and member counts. Those descriptions now earn their keep. You can understand the workspace without opening every channel. Open the sort menu to switch between alphabetical, recent, and most members. Alphabetical is calm and predictable. Recent is excellent when you're following active work. But most members can reveal the broadest gathering places, but size isn't quality. A tiny operations room may be more important to you than the largest public channel. Use join to filter rooms you already belong to. Archived is the recovery and reference lane, useful when you need historical context without reactivating old work. The browser and sidebar solve different jobs. The browser is discovery. The sidebar is daily focus. Treating them that way keeps navigation useful as the community grows. Close the browser and return to the organized workspace. We have not archived or deleted anything, and research notifications are restored. The decision rule is simple: public by default, private by real need, temporary by real expiry, and archive before delete. That one sentence will prevent most channel chaos. You now have a workspace that's ready for serious agent collaboration without becoming a maze. In the next lesson, we can add behavior on top of structure instead of asking agents to organize our mess. Buzz looks like a familiar team chat, right up until somebody expects an AI agent to read their mind. It won't. In this lesson, I'll show you how to write messages that humans can actually use, and the one small move that turns a normal update into a real agent request. Start with a normal channel update. A good message usually needs 3 things: context, current status, and the next action. I'm posting a tiny launch checklist so the team can understand it without needing a treasure map or 17 follow-up questions. The AA button opens Buzz's formatting tools: bold, italics, code, links, lists, quotes, and a few extras. Buzz also understands Markdown, which is faster once you've learned it. A bold heading and a short list are plenty here. Formatting should improve scanning, not turn the channel into a restaurant menu. Links can sit directly in the message, the paperclip adds media, and the smiley opens emoji. I'm attaching a harmless course image and adding 1 checkmark. If your update needs 12 emojis to communicate urgency, the emojis may not be the problem. Now I send it. This is a real channel post, but it is not an agent request. Codex is in the channel and can be online, yet Buzz will not wake it up just because the message sounds interesting. That behavior is intentional. Otherwise, every status update could become a very expensive group project. Before you invoke an agent, make sure it belongs to this channel. The member button shows 2 identities here: me and Codex. So if an agent never appears in autocomplete, check membership first. Do not start randomly reinstalling things. Buzz cannot mention an identity that isn't in the room. Here's the critical step. Type the @sign, begin the agent's name, and select the actual Codex result. Notice the identity chip. That chip is the difference between plain decorative text and a routed mention. Then give the agent a bounded job, review the checklist, pick the highest risk item, and explain it in 1 sentence. I send the request, and now Buzz has something it can route. The wording matters. There is source material, a clear decision to make, and a response shape. Compare that with thoughts, which is technically a prompt, but spiritually a cry for help. And there is the proof that counts: an actual Codex reply, not a green dot and not a hopeful loading indicator. I can open the reply in its thread, read the result, and add a reaction. Threads get their own lesson next, so for now, just remember that the visible reply is your success check. Buzz does expose edit for messages you own. In this preview build, though, saved edits were inconsistent in my tests, so I'm opening the editor and canceling instead of faking a successful update. The practical rule is simple: verify that the changed text actually appears before relying on it. Delete opens a serious confirmation, and this one is permanent. I confirm it, then check the channel, not just the button. The temporary note has vanished, so this attempt succeeded. During testing, the same preview build also returned a transient database timeout once. If the post remains, treat that as a failed delete, keep the evidence, and try again later. So the working pattern is simple. Write for humans with context, status, and a next step. Use formatting and media only when they clarify the message, and select a real @mention when you want an agent to act. Never paste secrets into a prompt, and never treat online status as proof. If the reply is visible, you did it right. A message can be perfectly written and still land in the wrong conversation. In Buzz, channels, threads, and direct messages look similar, but they create very different audiences. Let's make those differences obvious before somebody replies to the entire community with the confidence of a person who definitely meant to click somewhere else. This is a channel, a shared timeline for everyone who belongs here. Our Codex request appears in that timeline, but its answer is summarized underneath as one reply. Buzz keeps thread replies out of the main flow, which is useful when a focused discussion starts growing legs. Click the reply count, and Buzz opens the thread beside the channel. The original request stays at the top, Codex's real answer sits below it, and the composer now says reply in thread. Anything sent here belongs to this branch, so the context and the audience stay tied to this specific checklist instead of becoming a brand new channel topic. If the thread matters, open the root message menu and choose follow thread. The same menu changes to unfollow thread, so you can reverse it anytime. Following controls your notifications. It does not secretly invite people, address an agent, or change who can read the conversation. It is a bell, not a summoning ritual. There is one optional convenience under settings. Agents. Keep addressed agents active. When enabled, Buzz remembers agents you address for future messages in the same channel or thread, and you can remove them from the composer whenever you want. I am leaving it off here, so every routed request remains deliberate and visible. A direct message is different. It creates a limited conversation inside this community rather than posting to a shared channel. Hover direct messages and click the plus button to start one. You can include several people, but Buzz caps the conversation at 9 participants, including you, and changing the participant set creates a different DM. Search for Codex and select the real manage agent result. Notice that the composer now says message Codex in a direct message. Every other participant is already part of the audience, so I do not need an @ mention to route the next message. That is the key difference from an ordinary channel post. I will send a plain bounded request. Reply with exactly direct message received. There is no @ sign and no identity chip. The DM itself supplies the audience. If this were a channel, the same plain text would not invoke Codex. Here, Codex is a named participant in the conversation. And there is the only proof that matters. A real Codex reply saying direct message received. The message reached the agent without an @ mention because this is a DM with Codex, not because Buzz suddenly learned telepathy. Always verify the visible response instead of treating a sent message or online badge as success. The practical context rule is simple. In a thread, the root message anchors the branch. In a DM, the selected participants define the audience. In a channel, explicit mentions decide which agents receive a request. Also, an agent can only be mentioned inside a DM thread if that agent already belongs to the DM. So choose participants before the conversation branches. Use channels for shared visibility, threads for focused follow-ups, and direct messages for a small intentional audience. Follow threads when you want notifications. Keep persistent agent audiences optional, and never share private information, just because the room is smaller. Choose the conversation, choose the audience, then verify the reply. That is the whole routing checklist. Buzz gets much calmer once you stop treating every channel like a live emergency broadcast. Home is your personal triage desk. It gathers the work that may deserve attention, while the channels keep doing their noisy little channel thing in the background. Let's turn that into a routine you can actually use. Open the filter menu and you can separate all activity from projects, mentions, threads, needs action items, agent updates, reminders, and drafts. It's classification, not 8 different inboxes you need to worship daily. That's the map. So start with mentions when someone's addressed you, and needs action when Buzz is waiting for an approval or reminder. For a quick return visit, hover an item and mark it unread. The bold row channel dot and new divider make the state visible. Inbox options can show unread only, and mark all as read clears the current filtered queue. Buzz may keep the selected conversation on screen so you don't lose context, but the count is the reliable signal. I'll clear this one and restore the full list. When you know what you're looking for, search beats scrolling archaeology, click the visible search field and type highest risk, then narrow it within # course demo. Buzz also understands from after date and before date. Use dates in year, month, day format. I prefer the visible field because Control K can become link formatting when a composer has focus. The result list shows both the Codex answer and the original request. Choose the original request when you need the complete conversation. Opening the reply would start from that reply as a branch. That's technically valid and occasionally confusing. The root result brings us back to the checklist, its thread summary, and the real Codex answer together. Context recovered, Digital excavation successful. Unread is for soon, a reminder is for a specific later. Open the message menu and choose Remind Me Later. The quick choices cover 30 minutes, 1 hour, 3 hours tomorrow morning, and next Monday. You can also choose a future date and time and add a private note. I'll use 30 minutes, which creates a real reminder tied to this message. Back in Home, select Reminders and the saved message appears with its due time. Open message jumps to the source. Complete says the follow-up is handled. The clock snoozes it to a new time, and Cancel removes a reminder you no longer need. These are different decisions, so do not use Complete as decorative confetti. I'm canceling this demo reminder to leave the queue clean. Now decide what's allowed to interrupt you. In Settings, Notifications, Desktop Alerts are the master layer. Notify while viewing can also alert for direct messages in the conversation already open. Sound is configured per live category: direct messages, @mentions, thread replies, and needs action items. You can preview a sound and choose a different one without turning every event into a casino machine. View All reveals 4 agent job categories, but Buzz labels them coming soon, so they're preview settings, not working promises. The home badge is available for mentions and needs action items. And notice the red warning: Windows is blocking desktop notifications on this computer. Buzz can arm a category, but the operating system still controls delivery. We won't change system preferences just to make the warning disappear on camera. Here's the routine. Triage mentions and needs action. Mark something unread for a short return visit. Search with operators when you know the target. Set a reminder when timing matters. Then complete, snooze, or cancel it honestly. Finally, allow only the notifications worth breaking your focus. The inbox is a decision queue, not a second job, and that distinction makes Buzz dramatically easier to live with. Inbox and Pulse both look like feeds, but they solve opposite problems. Inbox pulls private work toward you: mentions, threads, reminders, and things needing action. Pulse pushes public updates outward. Think task queue versus town square. Mixing them together is how you end up treating a social post like a fire alarm. Pulse is still a preview feature in Buzz 0.5.4. Open Settings, choose Experiments, and you'll find Pulse described as an activity feed with notes, social posts, and agent activity. Enable it, and Pulse appears in the sidebar. Mine is already on, so I'll leave the switch alone and head back. Across the top, everyone shows public notes from the connected relay. Following narrows the feed to profiles you follow. Liked collects notes whose heart you tapped. Agents isolates public notes authored by registered agents, and mine is your own publishing history. But the little 4 beside agents is the number of registered agents here, not 4 unread updates. Tiny badge, surprisingly large opportunity for confusion. The empty states are useful evidence. Following is empty because this identity isn't following anyone yet. Follow controls only appear while the Pulse preview is enabled. Agents knows about 4 registered agents, but none has published a Pulse note, so that tab isn't a live run log, and it doesn't magically convert every Codex chat reply into a social update. The magnifying glass opens a dedicated Pulse search screen. In this installed build, the field is visible, but it doesn't return results yet. The button is effectively a preview shell. So use the main search everything field for working message search and treat Pulse search as interface that's arrived before the engine. Honest labels beat imaginary features. Now let's publish something real. Back on Everyone, click the composer and write. Course note: Inbox is for decisions. Pulse is for shared updates. Different streams, different jobs. The button can mention a profile, the paperclip attaches media, and the smiley adds emoji. For this note, plain text is exactly enough. Click the arrow once. The note appears immediately in Everyone, and mine confirms it belongs to this identity. A Pulse note can be liked, replied to, or shared. Notes from other people also offer a direct message shortcut. Replies keep a reference to the parent note. This is public social contexts, so post deliberately. Your future self does not need a breadcrumb trail made entirely of test messages. Here's the clean operating rule. Inbox is where you decide what needs your attention. Pulse is where people and agents intentionally publish updates for discovery and conversation. Following and search are still preview territory on this build, so verify the surface before promising a workflow. Use Pulse for visibility, not urgency, and Buzz suddenly makes much more sense. A busy channel has the memory of a goldfish. Great decisions arrive. The chat keeps moving, and 3 days later, somebody asks the same question with confidence. A canvas fixes that. It gives one channel a persistent markdown document for the brief, the checklist, or the facts everyone should stop rediscovering. Open the three-dot menu in the channel header, then choose Canvas. This room doesn't have one yet, so Buzz gives us a Create Canvas button. Nothing's hidden in a separate knowledge app. The page is attached to the room where people already work. That scope matters later. For now, it's pleasantly simple. One markdown document, one save button, and a cancel button that deserves more respect than it usually gets. I'll make this useful, not ceremonial. The title is Course Demo Brief. Under Goal, we say what the room is for. Under Ground Rules, we keep the operational facts. Mention an agent when you need a reply, verify risky output, and put durable decisions back here. So we add a checkbox list, and the shape is deliberately boring. If a teammate can answer what we're doing, and what still needs work in 10 seconds, the page is doing its job. Save it, and Buzz renders the markdown immediately. A canvas is the channel's current shared page, not another message in the timeline. Click Edit Canvas, add a final checklist item, then save again. That replaces the current document with a revised version. Buzz doesn't create a duplicate page or make everyone choose between competing copies. So keep the brief short enough to scan. If the canvas becomes a novel, the channel has quietly invented homework. Now, the agent test, I explicitly mentioned Codex because a name typed as ordinary text isn't a routed request. The task is read-only. Return the canvas title and the final checklist item, and don't edit anything. The mention chip shows us exactly which identity will receive the request before we send it. That's a useful safety pattern. Narrow the task, state the no-edit boundary, and send once. And managed agents receive the channel canvas as context, and can also use Buzz's authenticated command line without exposing the identity key. While Codex works, the activity line confirms that the managed agent is using Buzz's authenticated tools. The same surface is available from PowerShell, so let's look at the exact commands. Buzz canvas get reads the document for a channel, and canvas set replaces it. Content can come from standard input, so a markdown file fits naturally into automation. One channel has one current canvas, not a folder of versions. Right beside it, Buzz notes is separate. It's set, get, ls, and rm. Commands use an author's stable node identity instead of the channel identifier used by Canvas. Those two help screens show how Buzz addresses the data, but the real test is whether an agent can read it in context. Back in Buzz, Codex returns facts that only exist in this canvas, so this is grounded retrieval, not a lucky guess. A canvas belongs to one channel and keeps that room aligned. A long-form note belongs to an author and a stable slug with a title, summary, tags, and markdown body. Updating the same slug revises that durable note. It doesn't turn the channel canvas into an article library. Use a canvas for the current brief, rules, and checklist. Use a note for a guide, research summary, or reusable procedure beyond one room. In this Buzz version, that path is agents and the command line, so teach the supported surface rather than hunting for a desktop editor that isn't there yet. Use chat for motion, canvas for the room's current truth, and long-form notes for reusable knowledge. Update the canvas when the plan changes, not after the team has already argued from 3 different versions. That tiny habit gives people and agents the same source of context, which is exactly where Buzz starts feeling like a workspace instead of another chat window. Chat is great until the thing you need is a file, a frame, or an actual conversation. Buzz handles all 3 without sending you on a scavenger hunt through another app. We'll attach a normal document, review a video at a precise moment, and then open a live huddle. 3 jobs, 1 channel. And, mercifully, no link sharing archaeology. Start with the paperclip in the message composer. I'm choosing a small markdown checklist, and Buzz shows the file name before anything is sent. That pause is useful. Check the file, check the channel, and remember that the attachment inherits this room's audience. Send it, and the message becomes a clean file card with the original name and size. The download button brings the file back through Buzz instead of flinging you into a random browser tab. Video uses the same paperclip, but there's more happening underneath. Buzz calls the local FMPEG tool, normalizes the upload to a web-friendly MP4, and creates a poster frame. That's why a larger clip can take a moment before the send button is ready. Don't click the paperclip 5 more times like it owes you money. Wait for the thumbnail, verify it's the right clip, then send once. The posted clip already has a proper inline player. You can play, pause, seek, mute, and change playback speed without leaving the timeline. That's convenient for a quick look. For an actual review, use the arrow in the top right corner. Buzz opens a focused workspace with the video on the left and the comments on the right, so the feedback stays attached to the media instead of dissolving into around the middle, I think. I'll move the playhead to the canvas transition. Notice the time chip beside the composer and the checked option, comment at current frame. Now I can write one specific note. The canvas opens cleanly here. Keep this transition. When I send it, Buzz stores the comment with that time code. This is review context, not an edit to the video itself. The source clip stays untouched, while the discussion gains an exact anchor. And here's the proof that the anchor is useful. Click the timecode on the comment, and the player jumps straight back to that moment. If the feedback applies to the whole video, turn frame stamping off before you post. If you're replying to an existing comment, Buzz nests the reply under it, without inventing a second timestamp. Tiny details, but they keep review threads readable. Now for the Huddle button in the channel header. Starting 1 creates a live voice room and a Huddle card in the timeline. Along the bottom are the microphone and input controls, speaker output, the Huddle thread, participants, reactions, live transcription, and the option to bring in an agent. I'll mute first. A surprisingly advanced technique in group calls, then open the participant list. The captions button starts live transcription, and the active state makes that obvious. Buzz can also enroll managed agents such as Codex or Hermes in the room when that's actually useful, not merely because the button looks tempting. One boundary matters in this version. Live voice, the room lifecycle, participant events, and the transcription switch are real. A downloadable Huddle recording and separate participant tracks are not built yet, so don't promise a recording that Buzz cannot produce. Stop transcription when you're done, leave the Huddle, and the final participant leaving ends the room. Use attachments for durable files, video review for frame-specific decisions, and Huddles when typing has officially become the slow option. An agent in Buzz is not just a model wearing a charming little profile picture. It's a stack of decisions. Who the agent is, which runtime does the work, which model that runtime uses, where the work starts, who may trigger it, and where the answer goes. Miss one layer, and the quiet robot on your screen may become a very expensive decorative houseplant. Let's follow the whole path with Codex. On the Agents page, Codex has its own profile and a green status dot. The profile's the identity layer. Buzz gives the agent a public identity, shows who manages it, and tracks the rooms it belongs to. That's what a real mention resolves to later. The cute logo helps humans recognize it. The identity metadata is what makes the network care. The Runtime tab is a different layer. Here we can see the operating instructions, a running status, and the harness log. Running means Buzz has the managed runtime available. It doesn't mean a model is burning tokens in the background. The connection can stay warm, while the actual AI turn begins only when a valid request arrives. Open the edit surface, and the split becomes clearer. The harness is Codex, while the model says harness default. In this configuration, Buzz hands the turn to the Codex runtime and lets that harness use its own model choice. Other runtimes may expose a provider and model directly, so never treat identity, harness, provider, and model as 4 names for the same thing. They answer 4 different questions. Advanced settings control who can send instructions. This agent's owner only, which is the safest default for a machine with real files and connected tools. Parallelism controls how many conversations an instance handles at once. A working directory, when assigned, gives the runtime a starting workspace for relative paths and project context. Useful? Absolutely a security sandbox. No, the agent still operates with the authority of the runtime and the computer account behind it. The Channels tab answers another question. Where can this agent participate? Codex belongs to 5 rooms here, including our course demo channels. Membership decides where it can receive events. The response audience rule decides which people may instruct it. Those controls overlap in daily use, but they aren't interchangeable. But being in a room doesn't magically give every person in that room permission to steer your local tools. Now watch the request path. I type the @ sign and choose Codex from Buzz's picker. That selection creates the real mention chip. Simply typing the letters at Codex and leaving them as plain text would look convincing to a human, but it wouldn't carry the identity metadata Buzz uses for routing. I add one narrow, read-only question and send it. Keep the request specific, say what must not happen, and give the agent less room to improvise a surprise renovation of your hard drive. Buzz immediately shows activity on the message. That proves the managed runtime received the mention and started a turn. Activity can include progress, tools, permissions, warnings, and errors. It's useful operational evidence, but it isn't the final answer. The durable result appears as a reply attached to the original request. Open the thread, and there it is. Codex explains the working directory without reading or changing a file. That's the complete loop. Identity tells Buzz which agent you meant. The runtime performs the work. Model settings choose the intelligence behind it. Permissions decide who may trigger it. Channel membership decides where it can participate. The working directory supplies context, not containment, and the resolve mention carries the request from a visible message to activity, then to a posted reply your team can actually find later. Connecting Codex to Buzz sounds like one switch, but there are really three moving parts. The Codex command line tool, the adapter that translates between Buzz and Codex, and a signed-in Codex session. The good news is that Buzz checks those pieces for us. So instead of reinstalling software that already works, I'll show you how to read the diagnostics, configure the agent, and prove the connection with a real response. Start in Settings, open Agents, and find Agent Runtimes. On Windows, check the system prerequisite at the top as well. Buzz expects a Bash-compatible shell, and this machine has Git Bash available. Then use Check Again whenever you install, update, or sign in to a runtime that reruns Buzz's own diagnosis, which matters more here than asking a random terminal whether one particular command happens to be on its path. The status labels are wonderfully blunt. CLI needed means the runtime or its required command line tool is missing. Sign-in needed means the software is present but authentication isn't ready. And ready means Buzz can launch the runtime with the connection it currently has. Here, Codex is ready. Goose still needs its CLI, and Claude Code needs a sign-in, so we can see all three states without breaking anything for dramatic effect. Add Runtimes opens the setup catalog. The setup list is where Buzz guides you through a missing runtime. Installed shows what you've already connected to Buzz for Codex. The underlying pieces are the Codex CLI and the Codex ACP adapter. Authentication can use your ChatGPT account or an API key, depending on your Codex setup. But complete that privately, never on camera with a token waving hello to the internet, return here, and run check again. Since this machine is already configured, we can close the catalog and move on. Now open the existing Codex agent. The agent's public identity and the runtime behind it are separate. In the editor, the harness is Codex and the model setting reads harness default. That means Buzz sends the turn to Codex, while Codex keeps its own model selection. I also keep who can send instructions set to only me for a local agent with access to real tools and files. One important version note. In Buzz version 0.5.4, there isn't a per agent working directory box in this editor. Manage agents start from Buzz's default work area. The starting folder provides useful context, but it isn't a file system sandbox. The Channels tab shows where this agent can participate. We've already added Codex to our controlled demo channel, so there's nothing to change. So if your agent is missing from a room, add it here before testing. A healthy runtime sitting outside the channel won't receive the channel's events, which is the software equivalent of being fully caffeinated in the wrong meeting. Let's verify the entire path. In the demo channel, I type the @ sign and choose Codex from Buzz's picker. That selection creates a real mention. Plain text that merely looks like a Codex is not enough. The request is deliberately tiny. Reply with one exact sentence and do not inspect or modify any files. Narrow tests are easier to verify, cheaper to troubleshoot, and far less likely to become an accidental side quest. The activity indicator tells us Codex received the routed request and began a turn. Then the durable reply appears beneath the message. Open the thread, and there's our exact confirmation from the real Codex agent. If this doesn't work on your machine, walk backward through the chain, confirm channel membership and a resolved mention, check the agent's audience permission, return to agent runtimes, fix CLI needed or sign-in needed, and run check again. When the runtime says ready and a real mention produces a posted reply, your Codex connection is working end-to-end. Codex is connected. First, open your profile menu. Next, open Settings. Choose Agents, where Buzz manages local runtimes and behavior. Now click Check Again for a fresh runtime result. Buzz reruns discovery on this machine. Give Buzz a moment to finish the scan. Scroll down to the local runtimes. Hermes agent is ready. Buzz can reach Hermes ACP on this machine. Hermes still owns the provider and persistence setup. Buzz uses Hermes ACP for the connection, while Hermes keeps its model, tools, and configuration. And there is the current status. The green ready badge confirms that the adapter starts. It does not prove a model provider can answer a real request. If you see CLI needed, use the official Hermes guide. Provider setup stays inside Hermes, and tokens, configuration files, and local paths stay off camera. Return to Buzz. Now we are back in Buzz. Open Agents, open the existing Hermes profile. Here is the profile we will verify. This profile is managed by you. It belongs to two controlled course channels. A healthy runtime still needs channel membership. Open Edit Agent. The editor opens on its core behavior. These instructions keep Hermes concise, mention only, and privacy conscious. Scroll to AI configuration. The harness is Hermes agent. It tells Buzz which runtime should execute the turn. This verified profile uses custom model with GPT 5.5. The orange note says live models did not load for this provider. A normal model menu should match the model already configured in Hermes. Guessing creates a fragile setup. Advanced includes permissions and private local data, so it stays closed. Cancel without changing the working profile. Open channels. This is where channel membership becomes visible. Course demo is one controlled membership. The rehearsal room is separate, keeping practice traffic contained. Those controls are separate. Close the profile. Open course demo. Click the message box. Type the @ to find Hermes. The picker resolved Hermes. Now type one narrow read-only request. Send it. Hermes is working. The mentioned ship is the routing evidence. Plain text that merely spells Hermes would not trigger the agent. One precise request creates a clear success condition without granting unnecessary work. While Hermes works, leave the request alone. Duplicate messages only create duplicate work. Unexpected permission requests are a stop signal. Narrow the prompt instead of approving on autopilot. A normal local turn can take a moment. And there it is. The reply count just changed to 1. That is our signal that Hermes answered, and the thread is ready to open. Open the new reply thread. Now the thread opens with the proof. There it is, Hermes connection verified. That durable reply proves the complete route. The ready badge alone was not enough, and neither was the ACP check. This reply proves the model provider answered through Buzz. Silence usually means a broken link. Mention resolution, channel membership, instruction, permission, harness, model, or runtime readiness. The verified result stays on screen. Codex is a natural fit for focused software engineering work. Hermes is a general-purpose agent for broader tasks across files, terminal, web, memory skills, and vision. This is not a brand cage match. Use the runtime whose tools, provider, and permission posture fit the job. Buzz can talk to several kinds of agents, but one rule prevents setup chaos. Listed doesn't automatically mean ready. Here, Buzz separates compatibility from readiness. Git bash is the shared prerequisite. Each runtime gets its own status. Codex is marked ready here, matching the connection we already tested. Hermes is ready too. These are the two runtimes we'll actually use in this course. Add runtimes is a catalog, not a magical install everything button. We'll explore it without changing the machine. The setup list contains several presets. Each card explains the command or adapter Buzz expects, plus the vendor's setup guide. Cursor says CLI needed. Buzz expects the cursor agent ACP mode, so this card alone doesn't install cursor or sign you in. OpenClaw adds another layer. Its ACP command relies on a separate gateway daemon, and that daemon needs its own execution time credentials. So for anything outside the presets, Custom Harness registers a local command that speaks ACP over standard input and output. Give it a clear name. Buzz derives an ID, which becomes the stable internal label for this runtime. Keep both boring and obvious. Future you will approve. Command matters most. It must launch a real ACP speaking process. This registers a runtime. It isn't an install box. Arguments, environment variables, documentation, and install hints are optional, but treat environment values as secrets, and verify the command before saving. I'm closing without saving because this course doesn't need another provider, account, or credential. Back on the list, choose what is genuinely ready and verified end-to-end. For us, that is Codex or Hermes, the two we've actually tested. Catalog explored, chaos avoided. A good agent is not just a clever model with a cute name. It's a job description, a permission boundary, and a memory policy. Let's build all three. I created this draft ahead of time, so Buzz's one-time private key never appears in the recording. That's a credential, not course decoration. Start with a name that tells humans what the agent actually does. Research Scout's far more useful than agent number 7. Now give it a focused role. Separate verified facts from assumptions, cite sources, keep replies concise, and never change files, settings, accounts, or channel content without the owner's explicit request. That boundary matters. This agent inherits our already proven Codex harness. We're not adding a second provider or secret just to make the setup look fancy. Open Advanced, scroll to the permission controls. Who can send instructions stays on only me. Anyone or selected people can be valid, but both widen who can drive this host-backed agent. Parallelism stays at the app default. The instance pool is optional, and there aren't any environment variables. Fewer moving parts, fewer ways to accidentally leak a credential. And in Buzz 0.5.5, there isn't a dedicated working directory field here. The launch directory is context, not containment. Permissions still come from the workstation account. Save the definition. Restart the managed instance so the new policy actually applies. With that policy live, let's narrow where this agent can participate. Open Add to Channel. Keep the role on bot for this agent. Select the research channel. Confirm Research Scout in the research channel. Channel membership sets where the agent participates, only me sets who can instruct it. Open the research channel. Use the @ sign to open Buzz's autocomplete. Choose the real Research Scout identity. Plain text alone isn't an invocation. My test asks for one harmless memory and a judgment on an untested workflow. We're checking the response policy without giving it files, secrets, or permission to mutate anything. Buzz shows the agent working, so we wait for the real response. Open the reply to see the result. And there it is. The agent treats an untested workflow as an assumption, not a fact. Close the thread. Return to agents. Scroll back to the agent cards. Open Research Scout. Open Memories. The working rules survive the turn. Memory isn't a password vault or a dump of every conversation. It's curated, durable context. So that's the clean pattern. Narrow persona, narrow author gate, narrow channel scope, non-sensitive memory, and a visible reply that proves the policy is real. Buzz teams are useful, but they're not a tiny autonomous company hiding inside one card. The agent teams section is already open here. Think reusable fan out one template, several named agents, and you still control the routing. If older Buzz material calls these persona packs, this is the current version of that idea in 0.5.5. Create a team. I'm calling this one Atlas Research Crew. The description tells a human why it exists. Focused investigation, source checking, and concise synthesis. Now, add shared instructions. Separate verified facts from assumptions, keep handoffs explicit, cite primary sources, and finish with one concise recommendation. A team-wide rule should clarify collaboration, not become a novel nobody reads. For members, choose Hermes and Research Scout. Hermes gives us the technical investigation lane, while Research Scout gives us a source checking lane. Create the team. The menu gives us deploy, edit, duplicate, share, and delete. These sound ordinary, but this build has two important footnotes. Open duplicate, the name, description, and members carry over. But team instructions are blank. That is real Buzz 0.5.5 behavior. So a duplicated team needs its instructions reviewed and re-added. Cancel this copy. Now open share and prepare an export. Team only is the conservative memory choice, and JSON is the practical portable format. Core memory or all memory can include plain text, so don't treat a snapshot like a harmless screenshot. I'm stopping before export because Windows opens the real save as dialog on another monitor here. Buzz would save the file. We're not pretending that export happened on this screen. And on import, Buzz creates fresh member identities. Their old cryptographic identity doesn't travel, and clearing imported allow lists is the safer default until you deliberately restore trust. We're deploying Atlas Research Crew to course demo rehearsal, keeping the role on bot, and creating two course-owned agents. When the channel confirms Hermes and Research Scout were added, deployment is proven. Useful work is not. So the next step is a proper invocation. Use the @ to resolve the real Atlas Research Crew result, and Buzz expands the team into the exact Hermes and Research Scout mentions. That expansion is the important proof that both agents are targeted. Plain text would not be enough. My request gives each agent one small job on a fictional Atlas workflow. It asks for one technical verification and one source check, with no file access and absolutely no changes. Open the thread. The request is already sent, and a moment later we have real separate replies from Hermes and Research Scout. This is parallel fan-out, not automatic handoff. If I want Hermes to pass a result to Research Scout, I need to say that explicitly in the next turn. Troubleshooting starts in the course-owned agent profile. The activity row is still collapsed here, so it cannot explain this turn. Runtime confirms the managed process state, and harness log exposes adapter-level evidence. Use these surfaces to answer one question: where did the turn stop? And keep internal commands out of the narration. If the agent is actually stuck, stop the course-owned instance and wait for the stopped state. Start it again, then wait until the profile clearly returns to running. Use restart once, confirm the agent stays running, and move on. Repeated random attempts are not a recovery plan. Before we test delete, remember that the confirmation claims deployed agents stay untouched. In this build, the actual delete can still be blocked while agents reference the team. So I verify the result and never delete existing Hermes or Research Scout definitions just to make a template disappear. So the safe pattern is simple: focus team, explicit mentions, narrow snapshot scope, visible replies and human review. Teams save setup time, they don't remove responsibility. Projects in Buzz are easier once you separate two ideas. A project is the folder that groups the work, and each repository inside it still owns its access rules and Git authority. Same neighborhood, separate front doors. We're in projects. These existing cards are clean sample repositories, so we can see the layout before adding anything. The plus menu also includes issue and pull requests for this lesson. Select project. Give the project a name a teammate can recognize. I'm using B Garden Game, then choose the repository access channel. I'll bind this course repository to course demo, which is the group that should be able to discover and work with it. Add one useful sentence of description. A tiny sample project for learning Buzz repositories. The initial clone URL and web URL are optional. Leave them blank when Buzz is creating the empty starting repository. Use them only when you're linking a real remote you control. Now we're ready. Create the project. Buzz publishes the project and its first repository announcement. The new card begins with 0 commits, 0 pull requests, and 0 issues. And that's exactly right for an empty repository, not a tiny emergency. Open B Garden Game Files is the landing view. Main is the default branch, and Buzz clearly tells us that nothing's been pushed yet. Across the top, commits shows repository history. Issues tracks work. Pull request is for proposed changes. Contributors shows authors, and the terminal is the Git work surface. These are repository tools, not decorative tabs waiting for a future personality. Open access. The checkmark beside course demo is the repository's own access channel binding. This is the important boundary. Putting a repository in a project does not silently grant push rights, rewrite Git policy, or change permissions on an external host. Let's head back to the main projects page. Now select the activity view. The signed creation event is now shared history. Buzz brings conversation and repository activity together without taking over Git authority. But there is one current desktop limitation worth knowing. In Buzz 0.5.5, branch and tag protection is managed through the CLI, not a project-level settings panel. I'll show the commands help rather than pretend to apply a policy we don't need. The protection command expects a repository identifier and a full reference pattern, such as refs/heads/main. A real rule can restrict the push role, block force pushes, block deletion, or require patches. Test that on a course repository before protecting production branches. So that's the clean setup pattern. A clear project name, the correct repository access channel, honest optional URLs, and repository level policy. Projects organize the work. They don't magically inherit authority over it. This workflow gets much easier when you separate 3 objects. An issue says what should change. A patch carries an exact Git diff. And a pull request creates the review and merge decision around a push branch. They're related, yes, but they're absolutely not interchangeable. Type a title a teammate can scan in 1 second. Add a water counter to the garden HUD. It's specific, and specific beats mysterious every time. Enter the visible behavior and the useful constraint. The counter should update after every watering action and stay readable on narrow windows. That's enough context to act without writing a tiny novel. Submit the issue. Buzz publishes this as signed project work and carries us to the detail page. It records intent. It does not touch the repository files. The new issue is in backlog. That isn't an error and definitely isn't a tiny green light to edit main directly. The issue gives the team a shared target, but the code still needs an isolated, reviewable change. This is the real repository on a clean prompt. Authentication is already secure, so no private key appears anywhere on screen. Run the branch command for feature/water counter. Keeping the work off main gives the review a clean base and compare branch later. Apply the prepared water counter patch. This changes the working tree only. It doesn't commit, publish, review, or merge anything yet. Run the diff summary before committing. 3 tracked files changed: the HUD markup, the counter logic, and the responsive styling. Create one focused commit. Add water counter to garden HUD. A precise commit makes the later patch and review much easier to understand. Push the feature branch to the Buzz repository. This remote copy matters because Buzz can't create a real pull request until reviewers can fetch the compare commit. A local branch name by itself is just optimism wearing a badge. Now generate the exact commit with git format patch and publish that payload to Buzz, and the accepted event makes the diff available for discussion and reuse. It doesn't merge code, approve itself, or sneak past the review gate. A patch is portable evidence, not magical deployment confetti. Run the issue status help before leaving the terminal. Checking the installed command is safer than teaching lifecycle vocabulary from memory. The installed CLI lists the active state plus resolved, closed, and draft. But this lifecycle is separate from the pull request state. A merge can finish the code path while the issue doesn't move at all. Back in Buzz, the project and its real repository are ready. The pushed feature branch now exists on the shared remote. Refresh the repository data so Buzz sees the latest remote branches. It's the clean fix when a newly pushed branch hasn't appeared yet. Open pull request. And this area keeps proposed changes separate from issues and from the repository's already merged history. Choose the create action. Main is the base and feature/water counter is the compare branch, but direction matters here. Type the issue language again for the pull request title. That repetition helps reviewers connect the proposed code with the work request. Enter the outcome in one useful sentence. The remaining water stays visible after planting or refilling. Describe behavior a reviewer can verify. Submit the pull request only after the branch pair and description are correct. Buzz now publishes the review object around that, pushed commit. The pull request is active, with 1 commit and 3 changed files. That status means ready for review. It doesn't mean correct, approved, or safe to merge while everybody is at lunch. Open files changed for the actual diff. This is where the reviewer checks the markup, JavaScript, and responsive CSS instead of trusting a cheerful title. And test the relevant paths too. A readable patch isn't a substitute for verification. Open commits for the history being proposed. We expect one focused commit, not an unrelated backpack full of experiments. Small scope makes review faster and rollback safer. Return to conversation after reviewing the evidence. Comments and approvals inform the human decision. They don't replace it. The review surface is ready, but the branch is still merely proposed. Nothing has crossed into main yet. Choose merge only when the review is genuinely done. Buzz pauses at a confirmation, so it doesn't treat one button as irreversible authority. Confirm the branch pair, feature/water counter into main. The remote still has the final word and can reject a conflict or changed branch. That rejection is a recovery path, not permission to force the merge. The status is now merged. The review action is gone and main contains the change. That's the proof we need. A successful looking button alone would not have been enough. Here is the issue again, and it still says backlog. The merged pull request didn't silently resolve it. Someone must publish a separate status event when the work is truly resolved, closed, reopened, or moved back to draft. Code state and planning state remain deliberately independent. So that's the reliable loop. Define the work with an issue, isolate the code on a branch, publish the exact patch, review the pull request, confirm the merge, and manage lifecycle state explicitly. Buzz connects conversation to Git without erasing the human decisions in between. That separation is the feature, not paperwork wearing a tie. Here's the setup. 1 tiny bug, 2 capable agents, and 1 human who refuses to approve vibes. The bee garden says water, 3 out of 3, but the refill button is still active. Adorable garden, questionable hydration policy. Click the refill button while the can is already full. That'll give every later decision a concrete target. Now watch the app react. the counter stays full, the control stays enabled, and the status claims a refill anyway. So now we've got evidence instead of a vague feeling that the garden is being weird. Back in Buzz, split the roles on purpose. Hermes gets read-only investigation, Codex gets implementation only after I accept the diagnosis, and that keeps discovery from quietly turning into code changes. Click the message box in the shared course channel. It'll keep the investigation visible to the team instead of hiding it in a private scratchpad. Select the real @Hermes autocomplete identity, otherwise it'd just sit there looking decorative. Enter a bounded investigation request. Use the clean shared repository, reproduce the bug, cite exact file evidence, recommend the smallest safe fix, and don't make edits, commits, or branch changes. Send the request. The visible agent mention is the invocation, and the read-only boundary is now part of the shared record. Hermes traces the behavior to two places. The counter update never derives the button's disabled state, and the refill handler runs unconditionally. The recommendation is pleasantly boring. That's usually a good sign. Scroll through the evidence before accepting it. The proposed fix disables refill at full capacity, initializes that state once, and guards a full can request, and boring fixes tend to let you sleep. Now the human gate. I reviewed the diagnosis, the file evidence, and the suggested scope. Only after that decision does the implementation task move to Codex. Click the message box again for the implementation handoff. It'll preserve both the investigation and the decision that followed it. Select the real @Codex identity. That'll make the intended runtime explicit and prevent an ordinary channel message from masquerading as an agent task. Enter only the accepted scope. Codex must use an isolated course branch. Add a deterministic behavior check, verify the change, commit only the intended files, publish the branch, create a buzz pull request, and stop before merge. The detail matters because every branch and review gate is intentional. Send the implementation request. The task now has a branch boundary, a test requirement, a review destination, and a very clear stop sign. Codex reports a branch, a commit, 2 changed files, passing checks, and a pull request. Useful summary, yes. Proof, not yet. Confidence ends here, and verification begins. Run the first verification command in the real shared repository. The feature branch exists, tracks the buzz remote, and points to the reported commit. Check the reported commit directly. The identifier resolves, so the agent's summary is attached to a real Git object instead of a very confident ghost. Check the branch diff against main. Only app.js and behavior check.js changed, exactly matching the accepted implementation boundary. Run the JavaScript syntax check. No output here is good news. The file parses cleanly. Run the deterministic behavior check. It proves the initial full state, a valid refill, the disabled control, and the guarded second request. That is evidence. The buzz pull request is authored by Codex, targets main from the isolated course branch, and remains open. Open means reviewable, but it doesn't mean approved, merged, or magically safe. Open files change to inspect the implementation itself. Agent summaries are navigation aids. The diff is where the decision earns its confidence. Scroll to the app logic. The button now follows the water value. The handler exits when the can is already full, and startup initializes the control. That's the smallest safe production change from Hermes' diagnosis. The logic is local, readable, and limited to the broken behavior we actually reproduced. Open behavior check.js next. A fix without a durable check is just a future regression wearing a fake mustache. Scroll through the assertions. They cover the full initial state, planting, a legitimate refill, and the guarded repeat request. The test matches the user-visible bug. The evidence now lines up: diagnosis, 2-file scope, real commit, passing checks, and matching diff. That's enough to make a review decision without pretending the merge already happened. Type a review comment that connects the evidence to the decision. It records the limited scope, the correct guard, and both passing checks. A useful review says why. Submit the comment. The pull request now carries an independent explanation. It isn't just a lonely green button hoping everyone feels lucky. Commenting and approving are separate decisions in Buzz. The evidence is recorded, but the formal review state is still waiting for an explicit human choice. Open the approval dialog. It's the visible human gate, so the decision gets its own deliberate step. Enter a short approval summary. The scope and checks were verified, and the pull request stays unmerged. Confirm the approval. Buzz records the review decision, while leaving merge as a separate action. And that's the full pattern. Hermes investigates without editing. A human accepts the scope, Codex implements on a branch, the real evidence gets checked, and the pull request is approved without merging. It's a reviewed change with a visible human decision. Buzz workflows are where a chat app starts behaving like an operating system. The idea is simple. One event starts a small sequence of actions, but the current desktop release also has a couple of sharp edges. So I'll show you the useful path and the honest limits. And yes, those two cards are rehearsals. Automation rewards boring practice. Click Create Workflow to begin building. This is where the trigger, filter, steps, and channel scope come together. Before touching the definition, choose the channel deliberately. A Buzz workflow belongs to one channel, so its trigger watches that channel's events instead of casually roaming the whole community like an intern with admin access. Open the channel selector. The menu shows the streams available in this community and whether each one is public or private. Select Welcome Everyone. In Desktop 0.505, I verified that a multi-channel community can omit workflows saved in later channel IDs from this overview. And this channel is the reliable visible path on this demo community, not a universal naming rule. Switch to Edit as YAML. You'll find the form builder friendlier for discovery, while YAML makes the complete definition easy to inspect, copy, and review as one unit. Enter a deliberately harmless definition, a message posted trigger, a narrow text marker, and one delay step lasting a single second. There are no webhooks, no DMs, and no surprise messages anywhere in this test. It's a tiny workflow with a tiny blast radius. Read this from the top. The name is the workflow's label. The trigger listens for a posted message. The filter narrows that trigger to text containing our marker. Then steps describes the ordered work and enabled controls whether future matching events may start it. Go back to the visual form. This round trip is useful because it proves the YAML parsed into the visual builder instead of merely looking convincing in a text box. The upper form now carries the same name and description. The workflow is enabled, and message posted is the selected trigger. These aren't two separate workflows. They're two editors for the same definition. Scroll down now and let the builder settle. Now we can inspect the filter, and step keeping the pointer inside the dialog also prevents the page behind it from moving instead. Here's the operational core. The filter contains one unique text marker. Step 1 has a stable ID. The action is delay, and the duration is 1 second. Optional names, timeouts, and run conditions are available, but we don't need to decorate a 1-second nap. Scroll back to the top and let the builder settle. Before saving, check the channel. Name enabled state. Trigger, filter, step ID, action, and duration. A 10-second review here is cheaper than debugging and enthusiastic automation later. Switch to YAML for the final review. I would paste this version into a code review or keep it beside documentation because the whole behavior is visible without scrolling through separate controls. The final definition is intentionally small and readable. More actions do not make a workflow more correct. They just give a mistake more places to hide. Return to the form now. Buzz preserves the same values, so we can save from either editor without changing the meaning. Create the workflow now to store this definition in the selected channel. That still doesn't prove that a run has completed. The new active card is now visible. It shows the channel, trigger, and filter, summary, description, and date. Active means future matching events are allowed to invoke it. It doesn't hand us a tiny green certificate of success. Open the workflow card for its stored details. The panel exposes controls for editing or triggering it. The definition matches what we authored: one message trigger, one narrow filter, and one 1-second delay step. Below it, run history currently says no runs yet. Click trigger to send a manual execution request. That avoids posting the matching message first. Now the important version note. In Desktop 0.5.5, the trigger control can submit a run, but this panel does not yet reconstruct visible run history, so no runs yet is not proof of failure, and the click itself is not proof of completion. For consequential automation, verify the real side effect on screen. Close the detail panel. Keep the distinction clear. YAML or the form defines behavior, create saves it, active permits future triggers, trigger requests execution, and a visible side effect proves that the useful work actually happened. That is the safe foundation. Start with one narrow trigger and one reversible action, verify what users can see, and only then add messages, reactions, schedules, webhooks, or approval gates. Your future self will appreciate the lack of fireworks. Want the fastest way to spot fake automation proof? Watch the result, not the badge. In Buzz, active isn't the same as proven. These 4 course workflows are ready right now, but the badge only means they're allowed to listen. It doesn't prove that anything happened. So every working trigger has to earn its keep with a visible confirmation in the channel. Open the workflow builder so we can see the complete trigger menu. Choose the channel selector first. Select the course channel used for these safe demonstrations. Open the trigger menu and leave all 5 installed options on screen. Desktop 0.5.5 gives us 5 trigger types. Message posted watches new channel text. Reaction added watches emoji reactions. Schedule uses either a cron expression or a simple interval. Webhook accepts an authenticated HTTP request, and diff posted watches a buzz diff message. That's important. It means buzz event kind 4008, not every random git push on your laptop. Similar words, very different plumbing. Close the menu after confirming the installed options, and close the builder without creating another copy. Now, open the channel and test real events. Post a message containing the unique lesson marker. The filter ignores ordinary conversation and only accepts text with this exact marker. There is the visible result. Message trigger confirmed. The posted message is the cause, and the workflow's reply is the evidence. A green card could never tell that story this clearly. Post a clean seed message for the reaction test, giving the emoji one obvious target and keeping the result easy to read. Hover the real message and add a thumbs up reaction with the visible pointer. The workflow answers with the actual emoji from the event. You can also configure an emoji filter when one reaction should count and the rest can simply remain emotional support. Now return to workflows and start the scheduled test from a known disabled state. Open the disabled schedule menu. Edit the saved schedule definition before we turn it on. Turn on workflow is enabled. This allows future scheduler ticks to evaluate it. Save the active state and we'll wait for the workflow list to return before starting the timer. Return to the channel, then let the scheduled workflow fire on its own. The schedule workflow uses a 1-minute interval. A brand new interval doesn't fire immediately. It waits for a full interval, and the scheduler checks on a 60-second cadence. That's why we return to the channel and wait for the natural schedule trigger confirmed message, instead of clicking trigger and pretending time passed. For real work, use cron for calendar timing and intervals for elapsed timing. There it is, schedule trigger confirmed. The elapsed interval, not a manual button, started this run. With the scheduled event proven, return to workflows. Open the active schedule menu. Edit the workflow so the repeating test doesn't become channel wallpaper. Disable this workflow. The definition remains available, but future schedule ticks are blocked. Save the disabled state and check that the card now says disabled. Return to the channel and wait for its message history to finish loading. Message, reaction, and schedule have now been proven by their own natural events. For the webhook, open a real PowerShell window. Buzz generated this local URL and a one-time secret when the workflow was prepared. PowerShell lets us assemble the request one readable piece at a time, then compare the terminal response with the result in Buzz. Store the local webhook URL in a variable, so the request stays readable while we add the authentication and body. Read the one-time secret from the clipboard without printing it. And yes, secrets belong in headers, not in tutorials or accidental screenshots. Build the required webhook secret header for this authenticated request. Add a tiny JSON body identifying this course request and test. Send the authenticated post to the local Buzz listener for this workflow. Without that secret header, the same endpoint returns unauthorized. Switch back to Buzz and inspect the channel, not just the PowerShell exit status. Webhook trigger confirmed is the end-to-end proof. The request reached Buzz, authentication passed, the matching workflow ran, and its visible action completed. Switch back to PowerShell for the honest diff posted boundary. Type the installed command for publishing a diff. Run it, and let the terminal load the complete built-in help before we inspect it. The installed Buzz CLI exposes messages send diff. It requires a channel UUID, diff content, a repository URL, and a commit SHA, then publishes the special diff message the workflow expects. Repository announcements, patches, pull requests, and ordinary pushes use other event shapes, so do not label a generic Git event as diff posted unless you have verified the exact producer. Now check whether this shell has a Buzz private key configured. This shell reports false because no Buzz private key is configured for the CLI. I'm not going to extract the desktop identity just to manufacture a successful demo. The selector and command are real. A live diff trigger isn't claimed on this machine. Switch back to Buzz for the final trigger checklist. So that's the trigger playbook. Narrow the event, create a visible and reversible action, test the natural cause twice, and disable broad or repeating demos when you're done. Message, reaction, schedule, and webhook all pass that test here. Diff posted stays clearly labeled until its required Buzz diff publisher has a configured identity. Honest limits make better tutorials and much calmer production channels. Triggers decide when a workflow wakes up. Actions decide what it actually does after coffee. And this is exactly where you need to separate what the Buzz Builder offers from what this installed version can genuinely prove. Open workflows and select the action chain we prepared for this lesson. This first workflow is deliberately boring in the best possible way. That's a compliment. A narrowly filtered message starts it, Buzz waits for 2 seconds, and then it posts one confirmation back into the same channel. Small, visible, and very hard to misunderstand. Open the saved definition so we can inspect the 2 steps directly. It's deliberately The delay action pauses the run before the next step begins. This build accepts seconds or minutes and caps one delay at 270 seconds, which is 4.5 minutes. It's a short pause, not a calendar. Use delays for pacing and retries. Use a schedule when you actually mean do this later. The next action is send message. With a message trigger, Buzz already knows the current channel, so it can reply there without another channel ID. That's convenient, but your filter should be narrow enough that the workflow doesn't become the world's most enthusiastic coworker. Close the workflow editor so we can return to the course channel. Now open the course channel where the trigger message belongs. Post the unique lesson marker with a clean demonstration message, then watch it land. The trigger message appears immediately. Now leave the screen alone and let the delay finish naturally. And there is the separate confirmation. Action chain confirmed after a short delay. That is the useful proof. The trigger message and the delayed result are both visible in the channel. Return to workflow so we can inspect the saved action chain. Open the action chain menu. Choose Edit to reopen the workflow. Scroll down through the workflow until the second action step is back in view. Open the action selector on the second step so we can inspect the complete installed action menu without saving a change. Desktop 0.5.5 lists 7 actions: delay, send message, send DM, call webhook, request approval, add reaction, and set channel topic. That menu is the inventory. It isn't a promise that every backend path is finished. Choose call webhook in the draft and look at its fields. Call webhook sends an HTTP request outside Buzz. In this build, the destination must be a public HTTPS endpoint. Loopback, private, and reserved network addresses are blocked, redirects are disabled, and the request times out after 10 seconds. Those safeguards are useful, but they don't make the payload private. Cancel this draft without changing the proven action chain. Open the webhook workflow menu. Choose Edit to open the webhook workflow definition. Scroll down through the definition until the webhook request fields are clearly visible. The destination shown here is deliberately non-routable. While the useful structure stays visible: post, a JSON content type, and a 3-field body. Replace the placeholder only when you have an endpoint you control, proper authentication, and a clear reason to send each field. Cancel the editor and return to the workflow list. Return to the course channel. Click the message box. Type the unique webhook marker naturally, then press enter to post it in the channel. The message in Buzz is the cause. So now let us check the external receipt without exposing the receiver. Open Windows Run. Launch Windows Terminal and give it a beat to finish loading. This second surface matters. It proves the webhook actually left Buzz, reached the receiver, and carried the exact payload we expected. Run a read-only query that filters for lesson 27. The command asks the receiver for recent requests, keeps only the matching JSON body, and prints just the arrival time and body. Nothing else appears, so the verification stays focused and easy to read. There is the matching post receipt. The JSON body is exactly the 3 harmless fields from Buzz. For real work, use an endpoint you control, authenticate it properly, and send only the minimum data the destination needs. Close the terminal, return to Buzz, and keep that independent receipt in mind. Open Workflows again for one final look at the action menu. Open the action chain menu. Choose Edit to reopen the workflow. Scroll back to the second action step in the workflow. Open the action selector for the honest support boundary. Send DM and set channel topic are visible in the builder, but their VBall55 executor paths return not implemented. They aren't working actions here. Add reaction is also displayed, yet this installed build targets a relay route that isn't registered. We tested it with a real message ID and the documented emoji name. No reaction appeared, so I'm not going to perform interpretive dance and call that success. Request approval is different. It can suspend a run, but this build doesn't persist a complete approval record. That's its boundary. The next lesson gives that human gate its own careful test instead of squeezing it into a happy little checkbox here. Cancel the draft and finish from the workflow list. So the practical action playbook's simple. Prove side effects where they actually happen, keep message filters narrow, treat webhooks as data leaving buzz, and label unfinished actions without drama or wishful thinking. Delay plus send message and call webhook past their live tests here. The rest stay clearly marked until the installed behavior earns a stronger claim. Open workflows. We're testing failure, recovery, and proof. Start with the approval workflow. Here is the first important boundary. Buzz Desktop GORT 5.5 exposes request approval as a workflow action, so at a glance it looks ready, but in the installed app, triggering this step doesn't create a usable approve or deny card. The run pauses internally, then stops instead of giving a person a decision to make. In other words, the menu item is real, but the end-to-end approval experience is still early. Scroll to the step that should run afterward. This message is the downstream action. In a complete approval system, it should appear only after a human approves the request. Because this build can't complete that decision loop, the message never gets its turn. That's the distinction. Seeing a configured step isn't the same as proving that the step executed. Trigger the workflow once from its panel and watch what Buzz actually returns. Notice the run history area still says no runs yet. In this desktop build, that panel doesn't populate reliably, so an empty history isn't evidence that nothing happened. And it isn't evidence that something worked. A tidy blank panel is still just a blank panel. Close the workflow details. Open the course channel and check the result where people would see it. Search for the message that should follow approval. Type the exact expected text. There are no matches, which confirms the downstream message wasn't posted. We still don't have a usable approval card. So this workflow remains a product boundary, not a production approval gate. Don't put a real deployment, payment, or destructive action behind it until your installed version can prove the complete human decision loop. Close the search. Now return to workflows for a recoverable failure. Open the recovery workflow and inspect the exact failing definition. This workflow is intentionally safe to fail. Its first step calls a URL under example.invilbed, a domain reserved specifically for examples. The second step would post a unique confirmation in this channel. If the request fails, that confirmation can't appear, giving us a clean, privacy-safe negative test without exposing a real service or customer data. Close the definition. Return to the channel for the failure run. Place the cursor in the composer. Type the unique failure trigger. Post it as a real channel message. The trigger appears, but the confirmation doesn't. Buzz doesn't show a useful channel error here, so the trigger alone can't diagnose the problem. So we'll compare the saved definition with an independent side effect instead of guessing from silence. Open global search for the negative proof. Search for the exact confirmation text. No matches. That's our negative evidence. The expected side effect is absent after the failing trigger. It doesn't tell us every internal detail, but it does tell us the workflow didn't reach its final message step. Close the search. Return to workflows to repair the smallest failing field. Open the recovery workflow again. Open the editor for this workflow. Switch to the YAML view for a precise change. Focus the editor. Reset the editor to the top so the target line is deterministic. Click directly inside the invalid URL line. Select that complete line and nothing else. Replace it with a public test endpoint that returns a successful empty response. This endpoint is fine for a non-sensitive course check, but public test services aren't the place for secrets, personal data, or production payloads. Save the repaired workflow and wait for the updated definition to reappear. Close the details after confirming the new URL is stored. Return to the course channel for a fresh run. Focus the composer again. Type a new trigger that clearly says fresh run. Post the new trigger. And there's the confirmation. The webhook step completed. So Buzz reached the next action and posted the exact message we expected. This is a new run after a configuration fix, it isn't a retry button, and it isn't a resumed copy of the failed run. Precise language keeps the lesson honest. Open search one more time. Enter the exact confirmation text. The result appears in the correct channel, giving us independent, searchable proof instead of relying on a green badge or a hopeful feeling. So the save definition shows what should happen, the trigger shows what started it, and this message proves the visible side effect. Close the search. Return to workflows for the final auditability check. Open the repaired workflow and compare its saved state with the result. Run history still says no runs yet, even though we just observed and searched the successful confirmation. That's the clearest lesson in this build. Audit from multiple surfaces. Check the exact saved definition. record the exact trigger, and verify an independent result. And if one surface is incomplete, label that limitation instead of quietly promoting it to evidence. Close the workflow details, return to the channel. You've now got a practical recovery loop. Reproduce safely, prove the missing result, change one field, start a fresh run, and verify the exact side effect. It's less glamorous than clicking retry and hoping for cinema, but it's how reliable automation actually gets built. Let's build the first Buzz automation in this course that I would actually be comfortable showing to a team. The goal is simple. Somebody flags an item for review, a human makes the decision, Buzz performs one safe external action, and the result comes back into the channel where everyone can see it. No mystery green check marks, no crossing our fingers at a webhook. Open workflows, and let's inspect the design before we run anything. The design uses two small workflows. That's deliberate. The first one's for intake, the second one's for the human decision and the external action. Smaller pieces are easier to understand, test, and disable when something gets weird at 2 in the morning. Open the intake workflow. This workflow pattern listens for a thumbs-up reaction. In a moment, we'll run its channel-specific copy in our clean automation channel. A reaction is a nice low-friction intake signal. The original message stays readable, and the person reviewing it doesn't need to copy anything into a separate form. Scroll through the definition. When that thumbs up arrives, Buzz posts a structured review request. It carries a short item identifier, the public identity of the person who requested review, and one very clear instruction: add a check mark to approve. That's the handoff point. Automations organize the request, but a person still owns the decision. Close the intake workflow and open the approval workflow. One important version note before we go further. Buzz Desktop 0.5 exposes a native request approval action, but that action isn't wired end-to-end in this build. So this lesson uses a version-compatible human reaction gate. It is useful, and we can verify it, but it is not a durable approval record with a native deny path or resumable run. Scroll to the trigger and conditions. This workflow listens only for the checkmark reaction. Then it compares the reacting author with the public identity we've chosen as the reviewer. That long value is a public key, not a private key. Never paste a private key into a workflow. That sentence is free. The incident it prevents is not. Now look at the action order. The webhook comes first. It receives a tiny core-safe payload with a decision label and the target message ID. There are no secrets or personal details here. A public test endpoint is fine for this demonstration, but use your own controlled service for real team data. The step is also bounded by a 15-second timeout. More importantly, the final channel message has its own condition. It appears only when the webhook output status is exactly 204. That exact check matters because completing an HTTP request is not the same thing as completing the business action. In testing, a 503 response still gave the webhook step a status value. Without the next condition, we'd have celebrated a failure. Very efficient. Completely wrong. Close the workflow and open the safe automation channel where the team will see every visible result. Let's run the complete flow with a real item. Click the composer and type the review item. Keep it specific, so the approval request has a clear target. Post the message. Now add a thumbs up reaction. I'm opening the picker, searching for the exact emoji, and applying it to this message. There's our structured review request. Buzz kept the original message as the source, turned the reaction into a clear handoff, and told the reviewer exactly what to do next. Hover over the review request and add the checkmark. Again, I'll use the picker search so the reaction is exact and easy to verify. And now we've got the visible outcome. Approved, safe action completed, webhook status 204. That line appears only after the pinned reviewer identity passed and the external action returned the exact status we expected. That's the shape of a safe team automation, a human-readable request, an explicit decision, the consequential step, and proof in the same place where the work started. But we're not done, because happy paths are wonderful little liars. Remove the checkmark reaction from the review request. Now add the checkmark again. Same message, same reviewer, same reaction, but this creates a fresh trigger. Buzz posts another success message for the same target. In this build, removing and re-adding a reaction creates a fresh event and therefore a fresh workflow run. Buzz is not automatically deduplicating this event-triggered action for us. For a harmless course endpoint, that's just a useful warning. For a payment, deployment, ticket creation, or customer notification, it'll become a very expensive personality trait. The production fix belongs at the destination, as well as in the workflow. Send a stable idempotency key based on the target message or business item, store processed keys, and make repeated requests return the original result instead of repeating the side effect. Return to workflows and reopen the approval definition. This lets us compare the saved guardrails with the two visible outcomes we just created. But the workflow itself hasn't changed, only the reaction event was repeated. The other two failure checks are already built into this design. We've tested a 503 response, and the strict 204 condition prevented the success message. We've also tested a 1-second step timeout against a slower endpoint, and again, no success message appeared. Silence alone isn't a complete audit trail, so in a real integration, the Webhooks service should also record the idempotency key, decision, timestamp, and result. Buzz gives the team a visible outcome. Your destination gives you the durable receipt. After a failure or timeout, correct the smallest faulty field, save the workflow, and trigger a new event. That's a fresh run. In Buzz, Moat.5 isn't a retry button, and it isn't a resumed copy of the old run. Close the workflow and return to the channel, so we finish on the proof the team can actually see. So the full pattern is reaction-driven intake, structured context, a human gate, an allow-listed reviewer, a bounded external action, an exact success condition, and a visible result. Add destination-side idempotency, and this stops being a cute demo and starts looking like automation a real team can live with. Here's a real research sprint in Buzz, not a group chat where 3 robots politely invent the same answer. Our questions narrow. Should Pulse become the primary research record for this team? Reveal the channel controls because this evidence needs one dedicated home. Now open the channel browser for our destination. Choose Create Channel to start a clean research room. Name the channel Human-Led Research Sprint, keeping its purpose clear. Now add an evidence-first description, including the human decision at the end as well. Create the channel, then give the new workspace a moment to settle properly. Open the menu for this new channel. Open Canvas where the shared working brief will live. Create this channel's first canvas for the new brief. The canvas becomes our working brief. I'm spelling out the research question, which sources are allowed, what the final output must contain, and most importantly, who owns the decision when the agents finish. That last line keeps the automation firmly and visibly in its lane. Save the brief so every role sees the same scope. Canvas is our shared scratchpad. It keeps every role pointed at the same target while the conversation keeps moving. Close Canvas for the main channel view. Open the channel's member controls. Find Codex in the available member list. Add Codex, our implementation-focused agent, to this channel. Now search for Hermes. Add Hermes as the second available agent runtime, ready for its separate research role. And the member list now shows the human owner Codex and Hermes. Both agent runtimes are available on this computer. Close the member controls for the channel. I'll use Codex for the clean production responses in this example. The same role design can use Hermes after you verify its behavior for your project. Click the composer for the planner request. Select Codex from the autocomplete menu. Give the planner a narrow job. Separate planner, researcher, and critic roles. Define the evidence boundary and stop for a human decision before publication. Send the planning request and let Codex work. Open the planner's reply thread. This keeps the planning pass separate from the main channel and gives Codex a clean place to finish the outline without muddying the conversation. So the plan is compact. Distinct roles, official evidence only, a critic before the decision, and a final human gate. Good planning here is simply deciding who does what, which sources count, and where the automation must stop. Return to the composer for the evidence pass. Select Codex from autocomplete again. Limit the research to the official Buzz 0.5 release, the official repository README, and the interface installed on this computer. Ask for traceable claims and explicit unknowns. Send the evidence request and let the researcher work. Open the researcher's reply thread. The evidence stays attached to the exact request, keeping sources, unknowns, and the recommendation easy to inspect. And the result gives every surface a useful job. Threads preserve the visible discussion and source trail. Canvas holds the living brief long-form notes, carry a proof synthesis, while Pulse handles discovery and short updates. The official evidence does not identify a canonical primary record. Return to the composer for an independent critique. Select Codex from autocomplete for the critic role. Ask the critic to find the strongest unsupported claim and rewrite the recommendation without inventing product guarantees. Send the critique request for an independent challenge. Open the critic's reply thread. Separating critique from the original research makes every challenged claim and suggested correction much easier to review carefully before the human owner decides. But there's the correction. Buzz 0.5.5 does not officially define a primary research surface or promise stronger retention for one surface over another. Our workflow is a provisional recommendation, not a fake product guarantee. Close the critics thread for now. Open the channel menu again. Reopen Canvas for the human decision. And the brief still shows a pending decision. That's correct. The agents have compressed the evidence, but nobody has quietly approved the conclusion for me. Now enter Canvas edit mode for the human owner's final decision. Now the human owner makes the call. I'm marking this sprint as not yet because the open questions still matter. The supporting evidence stays in the channel threads. Canvas holds the working brief. Notes gets the approved synthesis, and Pulse carries only the short team update. That separation is the safety rail, so everyone can see where facts end, judgment begins, and accountability stays with us. Save the human decision back to the shared canvas. This is the point of a human-led sprint. Agents compress the work, but the person accepts the uncertainty and owns the call. Click the composer for the publication handoff. Select Codex from the @mention menu. In the message, I explicitly authorize the approved long-form note. I include its exact title, summary, tag, and body, then ask Codex to read it back word for word so we can verify the published result without trusting a vague success message. Send the authorized publication request to the selected agent. Open the publisher's verification thread. The publication receipt and exact readback stay together, making the final comparison quick and unambiguous. And the visible reply confirms that the note was created and its exact body matched on readback. A successful command alone would not prove the approved content survived publication. Close the note verification thread. Now open Pulse for the short distribution update. Pulse is the update layer here, not the evidence archive. If the research is a novel, Pulse is the movie trailer. Write one concise Pulse update for the wider team, reporting the outcome while pointing readers back to the source channel, Canvas, and approved note, instead of duplicating all the evidence. Publish this short Pulse update so the wider team gets the outcome immediately. So the sprint now has a complete trail, brief, plan, evidence, critique, human decision, durable note, and short Pulse update. Keep secrets, private keys, personal data, and confidential research out of community or relay posts. Buzz has a friendly desktop app, but underneath it's a serious command line surface for agents, scripts, and operators. This is where the workspace stops feeling like one app and starts feeling like infrastructure. I'm using the Buzz executable already installed on this Windows computer. I'll never print or paste a private signing key. If a tutorial asks you to put one on camera, that tutorial's become the security incident. First, point this command prompt session at the installed Buzz executable under local app data. Press Enter to keep that path for this session. Now, ask the CLI for its top-level help. Run that command and read the surface Buzz exposes. And the list is broad. Agents, messages, channels, Canvas, reactions, direct messages, workflows, feeds, notes, repositories, projects, patches, issues, pull requests, media, memory, and moderation. These aren't separate automation islands, they all speak to the same relay model. But the global options matter just as much. Relay commands need a relay URL and a private signing key. Output defaults to normalized JSON with a compact format for smaller agent context. Errors are JSON too, and distinct exit codes separate bad input, network trouble, authentication failure, conflicts, and other errors. Open the help for messages. Run it to inspect the message operations. So messages can be sent, read, searched, edited, deleted, and followed as threads. One version-specific footnote matters. An open-ended search can hit the relay policy gate, so scope message searches with explicit event kinds. Now inspect the channel command family. Run the channel help. This is the collaboration boundary. List and search channels, create or update one, manage membership, set topic and purpose, archive it or leave it. A script can do a lot here, which is exactly why its identity and permissions deserve adult supervision. Next, inspect workflows. Run the workflow help. The CLI can create workflows from YAML, update them, trigger runs, inspect run history, and approve or deny gated steps. The command is automation, the approval is accountability. Don't casually blur those two jobs. Now inspect moderation. Run the moderation help. Reports, bans, timeouts, restrictions, and the moderation audit trail live here. These are operator-impacting actions, not a fun place to test whether your autocomplete works. Let us deliberately try one read without supplying a signing key. Run the channel list request against a harmless, unreachable local address. Buzz fails close with a structured authentication error and exit code 3. That's useful automation behavior. A caller can distinguish missing identity from a broken network without scraping a paragraph of terminal drama. The local pack commands are the exception to the relay requirement. Type the local pack help command, press enter for the local pack command list. Validation and inspection happen locally, so they don't need a relay connection. They also produce human-readable output in this build, not JSON. JSON first is the relay contract, not a promise that every local utility formats identically. Now move from commands to architecture. The official repository describes Buzz as a self-hostable workspace where humans and agents share one relay. The relay is the source of truth. Reads and writes flow through it. The documented architecture has no peer-to-peer gossip or replication. A community is selected by its relay URL, and the default self-hosted shape is one host, one relay, and one community. That gives us a clean hosted versus self-hosted choice. Hosted Buzz means somebody else operates the relay. Self-hosted Buzz gives your team control of the deployment and gives your team the pager, the backups, the upgrades, the monitoring, and the bill. Self-hosting isn't a magic privacy button, it's a job description. For production, the official path is the compose bundle under deploy/compose. The root compose file is for development. Production operators should pin an image, terminate TLS, plan backups, and use the bundled run script instead of improvising administration in a random shell. And the ordinary Buzz CLI and Buzz admin are different tools. Buzz is the user and automation surface. Buzz admin ships inside the relay image for membership operations, such as add, remove, and list. If you don't operate the relay, Buzz admin isn't your new weekend hobby. Now open the official security model. Revisit this page before deploying a relay, changing authentication, or deciding who can see private channel data. Buzz authenticates WebSocket connections with NIP42 and REST requests with NIP98. Channel membership is the access gate. A non-member should not see a private channel, but the relay serving that channel still receives and stores its events. But the audit log is hash-chained and tamper-evident. That can reveal accidental corruption or a simple row edit. It isn't tamper-resistant against an attacker who controls the database and can recompute the chain. Production traffic should use TLS at the relay or a reverse proxy on desktop. Buzz uses the operating system keyring where available. None of that makes it acceptable to print a raw signing key into a recording repository, chat message, or model-controlled shell. There's even an open upstream security discussion about keeping raw agent keys away from model-controlled processes. The practical rule today is simple. Prefer narrowly scoped tools and dedicated identities, expose the least authority possible, and treat every key like the identity it can impersonate. So here's the operating checklist. Use the CLI for structured, repeatable work. Scope searches and permissions. Keep human approval around consequential actions. Choose hosted service for convenience or self-host only when your team can own the full operational burden. Control's valuable, but only when somebody is actually controlling it. Alright, this is the capstone. We are going to build one human agent operating room that connects the big Buzz ideas without pretending the agents are tiny executives with unlimited authority. Buzz is already installed and configured here, so we can start where real work starts, inside the community. Reveal the channel controls. Open the channel browser, where the room gets its own clean boundary. Choose to create a new channel for this focused piece of work. Name it Capstone Operating Room, because mysterious channel names are how future you starts plotting revenge against present you. Give it a plain English purpose, one reviewed agent task, and one safe follow-up with no room for scope creep. Create the channel. The structure now exists before the agents arrive. Open the menu for this new channel. The shared brief lives one level deeper. Open Canvas, our durable shared brief. Create the canvas so the room has durable context from the start. Now, write the operating rule before any agent gets involved. The outcome, the roles, the safety boundary, and the current status. The human owns the decision. Codex reviews the task. Hermes supplies investigation context. No secrets, destructive actions, or publishing without human review. Writing the rules first prevents a quick response from quietly becoming permission for a reckless action later. The written boundary matters more than the speed of the reply. Save that brief and give the room a stable starting point. This canvas is the room's memory, not decoration. Anyone joining later can see what success means and what is explicitly out of bounds before they touch the task. Close Canvas for a moment so we can bring the two agent teammates into the room. Open the member picker and keep the channel's role list intentional. Search for the installed Codex teammate. Add Codex to the channel as the bounded implementation reviewer. Now search for Hermes. Add Hermes as the investigation teammate for context and second opinions. We now have 3 members, 1 human and 2 agents. That is a collaboration shape, not an approval hierarchy. Close the member panel now that every role is visible. Codex and Hermes can recommend, investigate, and challenge assumptions. The human still decides what happens next. If that line gets fuzzy, the operating room has already failed its first test. Click into the composer. Type the @ and the agent's name. Select the real Codex autocomplete identity. Plain text that merely says Codex is just a message. This mention is the invocation. Give Codex a bounded review. 1 failure mode, 1 fail close safeguard, 2 short sentences, and absolutely no file changes or publishing. A good prompt defines the job and the fence around it. Send the request. Now the important reality check. This final live request did not return a visible reply after 75 seconds. I inspected the setup, retried once, and the retry was silent too, so I'm not going to invent a success state. Silence is a failed run, not a creative invitation to lie to the viewer. This screen is earlier verified rehearsal evidence, not the final run. In that rehearsal, the same real mention produced a visible Codex reply describing the failure mode and the safeguard. Useful evidence. Yes. Permission to pretend the final request worked. Absolutely not. Return to the final operating room channel and its durable decision record. Open the channel menu again and return to the room's durable record. Return to Canvas, where the final run's outcome has to be recorded honestly. This is the durable record every teammate should see. The rehearsals are identified as evidence, the final live timeouts are written down, and no downstream action is approved. I'm reopening it cleanly so the final course capture shows exactly that state. Edit the canvas so the stale waiting state can become a real decision. Focus the shared document, because this is where the human decision becomes durable. Record what actually happened. 2 rehearsals produced evidence. The final live request timed out, the decision is hold, and no downstream action is approved. The recovery rule is inspect once, retry once, then treat continued silence as failure. That is less glamorous than fake certainty and much more useful. A visible failure with a documented boundary is safer than an invisible assumption that somebody else approved the next step. The room can now recover from evidence instead of guessing from optimism. Nobody reading it later has to infer whether silence meant permission, success, or somebody else's responsibility. Save the human decision so every teammate sees the same boundary. Now the durable record is unambiguous. Hold. The agents did not approve anything, and neither did the human. This is what fail closed looks like when it is written down instead of vaguely implied. Close the overlay. Open workflows where bounded automation can follow an explicit human signal. Create a workflow for 1 safe local follow-up. Open the channel picker. Search for the Capstone operating room and keep the automation inside its intended scope. Select that channel and bind the automation to this room only. Continue to the workflow editor. The workflow listens for a checkmark reaction and posts 1 local message saying human review was recorded and no external action was taken. It does not deploy, publish, delete, or message anyone outside Buzz. Boring automation is underrated when the alternative is exciting cleanup. Validate the workflow definition. Create the valid workflow. Buzz 0.5.5 may still show an empty workflow list here, so the list alone is not our proof. We test the behavior next. Close the workflow screen. Return to the operating room channel where the human signal will be visible to everyone. The human posts a narrowly scoped review, approval to record 1 local follow-up only. Post that review so the human boundary is visible before the reaction appears. Add the checkmark reaction that triggers the workflow and nothing broader. That tiny signal is deliberately narrower than a general approval to act. The automation may record follow-up, not make a new decision. And there is the follow-up. Human review recorded, no external action taken. The trigger worked, the scope stayed local, and the message says exactly what happened. That is stronger evidence than a pretty workflow card. Open projects. This is where Buzz can organize durable repository and work context across commits, pull requests and issues. We are not creating new project state in the Capstone. We are checking that the operating room can point into the wider work system without turning the channel into a junk drawer. Open Pulse for the short status layer, not the durable evidence record. Write the truth in 1 compact update. The human recorded a hold after live agent timeouts. The safe follow-up stayed inside Buzz, and the durable evidence remains in the channel and canvas. The sentence stays useful because it names both the outcome and the boundary. Publish that status. Pulse helps people discover what changed. It is not the source of truth. The decision, evidence, and recovery rules still live in the operating room. Finally, open settings with control comma. Before you call a room operational, verify membership and agent permissions, keep recovery material backed up, but never expose it on camera. Review workflow runs and moderation responsibilities, understand cost and privacy boundaries, and keep Buzz updated. This machine is running version 0.5.5. The software will evolve. The human gate should not quietly evaporate with the next release. And that is the whole operating room. Agents can help, evidence stays durable, automation stays bounded, and the human owns the decision.